Starting with numerical number 20, a big dumbbell is prepared by using a uniform rod, of mass 60 gram and length 20 centimeter. Here you have a rod whose length is 20 centimeter and mass is 60 gram. Mass is 60 gram and length is 20 centimeter, means from here till here it is of 20 centimeter. Two identical solid spheres of mass 50 gram and radius 10 centimeter each are at two ends of the rod. Means, of course, shape of the dumbbell is somewhat like this. So here mass is 50 gram, and the radius of the sphere is 10 centimeter each. After that, calculate moment of inertia of the dumbbell when rotated about an axis passing through its center and perpendicular to the length. This is the axis of rotation of the system. So your dumbbell is rotating in this format. This is how your dumbbell is rotating about an axis which is perpendicular to this rod and passing through the center of the rod. If it is passing through the center of the rod, means this is 10 centimeter and this side is 10 centimeter because the whole length of the rod is 20 centimeter. Now if you check the central point of the sphere, then this is the center. If you draw axis from the center of the sphere, then this axis and this axis, both of them are parallel to each other. So in this numerical, we are going to use parallel axis theorem. Now let's see how parallel axis theorem is. A short summary of parallel axis theorem. This is the axis of rotation. So if you want to calculate moment of inertia along this axis, and this is that center, and if I draw the axis along the center, in a similar way how I have drawn the axis at the center of the sphere. So this two axes becomes parallel to each other. So here we can apply parallel axis theorem to find the moment of inertia. Here I will apply parallel axis theorem to find moment of inertia about the axis of rotation. This is that axis of rotation. So similarly, here the axis of rotation is parallel to the axis passing through the center of the sphere. Now if I want to find the moment of inertia of the whole system, then we have rod and two spheres. Means moment of inertia of rod plus moment of inertia of two spheres. Let me call the sphere as S1, moment of inertia of this sphere and moment of inertia of this sphere. So I can write this, both the spheres are identical, so I'll write it as 2S. Now just for the rod, the axis of rotation is passing through the center and it is perpendicular. So in that case, if the axis of rotation is passing through the center, then the formula for moment of inertia is ml square upon 12 plus 2. Now in this case, the moment of inertia for the two spheres, we will go with the formula of parallel axis theorem. Now in this case, the distance, this is the distance, perpendicular distance between the two axes. This is your main axis of rotation and this is the central axis. Here IC is the moment of inertia along this central axis. So your I0 will be IC plus mass of the sphere and the square of the perpendicular distance between the two axes. So in this case, if I want to find out the moment of inertia along this axis of rotation, then I'll have to calculate moment of inertia. Then I'll have to take moment of inertia for the central axis of the sphere, that is IC plus mass of the sphere and perpendicular distance ka square. Now here the mass of the rod is 60 gram, length of the rod is 20 centimeter. The moment of inertia moment of inertia for the sphere along the central axis is given by the formula half mr square. If you see in the section, formula section, then you will get for sphere if the axis of rotation or the moment of inertia along the central axis, the formula is half mr square plus m h square. Six twos are 12, 6 tens are 60, 2 ones are 2 fives are. So it is 5 into 20 ka square, that is 400 plus 2 m, we can remove common, so we have half r square, radius ka square. Radius kiska hai? Of sphere, and the radius is 10 centimeter, so that becomes 100. 10 का square, मास तो बाहर चला गया. h square, तो perpendicular distance कितना कैलकुलेट किए थे हमने? This is 10 centimeter, and of course this is radius. If radius is given 10 centimeter, so this 10 and this 10, ये radius of the sphere is 10 centimeter. So this total perpendicular distance becomes 20 centimeter. So here 20 का square will give me 400. 2 5s are 10, 2 zeros are 0. So it is 5 into 400. 5 4s are 20, and this 2 0 plus 2. Now mass of the sphere, that is 50 gram. 50 plus 400. So it is 2000 plus 2 into 50. 2 5s are 10, that is 100. 50 plus 400, 450. It is 2000 plus, if you multiply 4 5 with 3 zeros, now add 4 5 with 3 zeros and 2 with 3 zeros, so this will give me 4 5 6 7 47,000 gram centimeter square. I might have made any mistake. Let me check the mistake.
Okay, now if you see the formula for uniform rod and the axis is passing through the center, see, perpendicular to the length and passing through the center of the rod, in that case moment of inertia of the rod is ml square upon 2l. We have taken this. And for sphere, if the axis is passing through the center, then moment of inertia is 2 upon 5 mr square, and we have taken it as 1 upon 2 mr square. So if you are doing that, even you will be in the problem and you will get the answer as wrong. So now I have made the changes. Moment of inertia for the sphere when the axis is passing through the center is 2 upon 5 mr square. So 2 upon 5 mr square, m is out, m is as common, taken out as common. So r square, radius of the sphere is 10, so 10 ka square is 100. So you have 100 over here, so 5 ones are 5 2s are 10, 5 zeros are 0. So 2 2s are 4, 40. So here we will have 40. Here we will have 40. So 400 plus 40 will give me 440. So this will give me 440 into 100, 44,000, and this 44,000 plus 2,000 will give me 46,000. 46,000 gram centimeter square. Okay, so in this case, means for rotational dynamics chapter, you will have to be thorough with the formulas of moment of inertia. See, half mr square is the formula for solid cylinder or uniform disc. For a uniform disc or solid cylinder, if the axis is passing through the center, then the formula is half mr square. And even for the ring, if you see, for the ring, if the axis is passing through the diameter, then also the formula is half mr square.